नमस्कार दोस्तों, वेलकम टू गेट वाला। मैं हूं सतीश कुमार दुर्शेट्टी, फैकल्टी ऑफ मेजरमेंट्स। मैं आप सब लोग को स्वागत कर रहा हूं बेटा हमारा यूट्यूब सेशन के लिए। क्रैश कोर्स ऑन मेजरमेंट चालू हो गया है। आज का लेक्चर नंबर 3 चल रहा है। सो इलेक्ट्रिकल एंड इंस्ट्रूमेंटेशन पीपल के लिए दोनों के लिए टॉपिक है। एंड जो टॉपिक्स हमने डिस्कस कर रहे गेट डबल ई एंड गेट इंस्ट्रूमेंटेशन का पीवीक्यूज भी कवर कर रहे। सो लास्ट क्लास में हमने मेजरिंग इंस्ट्रूमेंट्स तक आगे चुका है। मूविंग एरन का बेसिक स्टार्ट हो चुका है। पीएमएमसी का प्रॉब्लम्स भी करवाया है। So if you see recap of previous lectures, so what we have discussed in previous lectures, last class one of the first lecture में error analysis हो चुका है। So first lecture was error analysis, first lecture was error analysis। इसके बाद measuring instrument डिस्कस किया था। measuring instruments में PMMC हो गया, PMMC रेंज एक्सटेंशन, नेक्स्ट इसके बाद गेट पीवीक्यूज भी हमने डिस्कस किया था। गेट पीवीक्यूज आल्सो वी हैव डिस्कस्ड। आज का क्लास में हम डिस्कस करेंगे मूविंग एरन इंस्ट्रूमेंट्स, सम बेसिक्स पढ़ाएंगे जल्दी से जल्दी, एंड देन वी विल गो फॉर one of the important instrument for the gate examination, that is a dynamometer. So dynamometer, okay, so that we can go for the three-phase power measurement. Three-phase power measurement and 2 wattmeter method also we'll discuss, if possible the time permits. 2 wattmeter method, okay, and इसके साथ साथ gate PVQs also we are going to discuss. Clear all of you? जितने लोग लाइव में हैं मुझे एक बार वॉइस कंफर्मेशन कर दीजिए। कत्ती सुजाता, गुड मॉर्निंग। So good morning to one and all. So before starting the session, this is my telegram id. आप टेलीग्राम आईडी को नोट कर दो बेटा। फॉर 1 minute आई एम गोइंग टू कीप दैट। गुड मॉर्निंग संतोष, गुड मॉर्निंग। चलो आज का क्लास में हम डिस्कस करेंगे, बिफोर गोइंग फॉर द सेशन विल डिस्कस फॉर द मूविंग आयरन इंस्ट्रूमेंट। सो मूविंग आयरन इंस्ट्रूमेंट का फॉर्मूलास कैसे होता है उसके बारे में डिस्कस करेंगे। सो मूविंग आयरन, लेट अस गो फॉर द मूविंग आयरन। तो जस्ट प्लीज कंस्ट्रक्शन के बारे में आपको नोट्स खत्म कर सकते हैं। मूविंग आयरन इंस्ट्रूमेंट कैसे काम करता है। मूविंग आयरन इंस्ट्रूमेंट में द फिक्स्ड पार्ट इज, मूविंग आयरन इंस्ट्रूमेंट में there is a fixed part called electromagnet. The fixed part is the electromagnet. Electromagnet means what? It is not permanent magnet. Electromagnet means it is a coil. Electromagnet, that means it is a coil. Okay. And the moving part is the iron disc. Moving part is the iron disc. Okay. So there is a, I'm drawing a rough diagram for you, not a perfect diagram. I'm drawing a rough diagram. This is the coil in which the current is traveling. So there is a spindle like this. इधर आएगा spindle. So this is the spindle. And for this spindle we are having a disc here, iron disc here. And now from the iron disc, so this is the movement. So here comes the pointer. Okay, so this is our display. Okay, so now when a current travels here now, so there is a amount of flux, so it acts like a magnet. So that's why it is called as electromagnet. Is audio video clear? Is audio video clear, my dear? Yeah. So see here, agar current travels now, what happens now? Because of the current there is a magnet. So for a change in current there is a change in flux. The change in flux creates some attracting force. So because of the attracting force, what happens? This particular iron disc will start moving this side. Where iron disc starts moving here, there is a deflection. Okay, so as the air gap reduces, the reluctance also reduces, because it was here iron disc, this is a ferrous. So it was here, now it was attracted because of this flux. It was attracted because you know that for a magnetic material nearby, if iron comes, it will be attracted, it also become like a magnet. So now it comes closer, attractive force, there is a deflection. Because of this attractive force, reluctance reduces, this flux gets linked here also. As reluctance decreases, flux increases, self-inductance increases. So for a change in current, so there is a change in flux, so there is a change in inductance. Okay, so the amount of inductance for the deflection dl by d theta, so that is given for your proportional. Theta is proportional to your dl by d theta. So accordingly you are going to get the reading. And the most important thing is it is electromagnet. So for AC as well as DC it will act like a magnet. For AC as well as DC it acts like a magnet. So that's why moving iron instrument is suitable for both AC measurement and DC measurements. So if you see the expressions of this, the expressions of this deflection torque is given by 1 by 2 I square dl by d theta. So this expressions you have to remember, my dear. So keep this in the box. Next, controlling torque TC is given Kc theta. So this is the expression. Okay, so now at steady state what happens? Steady state, the deflection torque is equal to controlling torque. So 1 by 2 I square dl by d theta is equal to Kc theta. So if I write theta is equal to 1 by 2 I square by Kc dl by d theta. So it is working on a self-inductance principle. So we can write theta is proportional to I square. Theta is proportional to I square. Similarly, we can write theta is proportional to V square also. So one of the interesting thing here is it is I square na. So it is going to give a RMS value. It is going to give a RMS value. So this is the RMS value it is going to give. So it is suitable for both AC as well as DC, my dear. AC as well as DC. समझ में आपको? That is the context you have to understand. AC as well as DC. Is it clear? So now if I take the graph is like this. So this is our I. So this is our theta. Theta is proportional to I square. So the graph will be non-uniform graph. The graph is not a scale. The graph is a non-uniform graph. So this is a non-uniform graph like this. So for the smaller values of I, the readings are crowded like this. The readings are very, very crowded for the smaller values. And for the medium values, the values are very much linear. And for the larger values, the readings are very much spacious like this. इसका मतलब क्या है ना? You have to understand. The scale is not a uniform scale. It is a non-uniform scale. The scale is a non-uniform scale. I mean to say, if the current is suppose 0.1 ampere, the theta is how much? Proportional to I 0.1 square. So it will be 1 by 100. So that means 0.01 degrees, like that. In that proportion it will come. If I is equal to 0.2 amperes, it will be 0.04 degrees. So these readings are very much crowded here. So these are called crowded readings. So these readings are crowded. Okay. So next, when I is equal to medium value, suppose 1 ampere, then theta is equal to I is equal to 1.5 amperes, then theta is equal to 2.25. So they are linear here. So this particular zone, we check. If we check this particular zone, this zone is called linear. But when you go for larger values, suppose if you take 2 amperes, theta is equal to coming 4. If I take I is equal to 5 amperes, theta is coming 25. See the space. So these are called spacious values. So ये है spacious. Okay. So that's why the scale contains different types of reading. समझ में आपको? Is it clear? So that's why the scale is called non-uniform scale. Please make a fast. Non-uniform scale. So moving iron ammeter, moving iron voltmeter. Both are like that. Make a note of these points, my dear. Done. Noted? Chal. Now let us go for the question. Try to answer this particular question. A moving iron ammeter produces full-scale torque of 240 micronewton per meter with a deflection of 0 to 120 degrees. With a deflection of 120 degrees. Okay, with a deflection of 120 degrees, edge. Deflection of 120 degrees at a current of 10 amperes. The rate of change of self-inductance of the instrument at full scale will be dash. So I'm attaching the poles. So try to understand the poles. 6 students have joined here already. So pole use करो, जल्दी से जल्दी आंसर कर दीजिए बेटा. The right answer is option B. So leaderboard पर कोई नहीं आया. What's the problem? So see here, what is given in the question? A moving iron ammeter produces a full-scale torque. So torque is given as 240 micronewton meter with a deflection of 120 degrees. Theta is given as 120 degrees. And the current is given as 10 amperes. So he's asking the rate of change of self-inductance. dl by d theta he is asking. So the deflection torque I can take it as 1 by 2 I square dl by d theta. Okay. So this is 240 micronewtons, that is 10 power minus 6, 1 by 2 I square, that is 10 square into dl by d theta. So that will be how much now? So if you simplify, that will be how much? 480. इधर आएगा 480 into 10 power minus 6, 10 power minus 2, 10 power minus 8 dl by d theta. 48 into 10 power minus 10 or 4.8 into 10 power minus 6 dl by d theta. So what are the units? 4.8 micro, this is Henry per radian. So the right answer here is 4.8 microhenry per radian. Option B is right answer. Okay, Katti Sujata, poll is not getting. Why poll is not getting? Okay, okay, I will come. Chalo, let's go for the next question. Yeah, try to answer this question better. Make it fast. 30 seconds. Okay, he police. Right, right, right. I think poll will come now. Okay, suppose just it is at 2 volts. I think ये अभी लीडर्स पोर्ट नहीं आ रहा है, ओके छोड़ दो. So actually the PMMC question है, लेकिन suppose if I'm using moving iron, so there is a voltage of DC voltage, there is a DC voltage, so there is a DC voltage and a source of this is a voltage, this is a V1, this is a V2. V1 is equal to 2 volts, V2 is equal to 3 sine 40 volts. Now suppose, what is the question? In the question he has given, there is a PMMC is mentioned, there is a moving iron is also given. Suppose, let us take this a PMMC, let us take moving iron. Can you tell me what the PMMC? The PMMC will measure only the DC voltage, that is 2 volts. Okay, so the answer is 2 volts. But can you tell me the answer for the this one? Moving iron. For moving iron, how much it is going to come? Can you measure? Can you tell me anyone? Hi Lingala Sathish. Still you have not settled in the job? क्या हो गया भाई, आप जॉब में सेटल हो गए? नहीं, बहुत साल से आप मेरा लेक्चर्स फॉलो कर रहे हैं, क्या हो गया, जॉब आ गया? नहीं, जल्दी बताओ. आपने यू आर प्रिपेयरिंग फॉर जेनको ट्रांसको, यू आर फ्रॉम आंध्रा, आई नो. हैव यू सेटल्ड एनी जॉब? यार, आई विल फील हैप्पी इफ आई गॉट अ जॉब. यू आर स्टिल वर्किंग फॉर द जेनको ट्रांसको. ఏపీ ట్రాన్స్కో రాలేదు, వస్తే టాపర్ నేనేలే సార్. ఎప్పుడు వస్తుంది రా నాయన? ఎంత ఏజ్ ఇప్పుడు? 30కి వచ్చినావా? పెళ్లి చేసుకోవా ఇక? ఇట్లా ఎగ్జామ్ రాసుకుంటే ఉంటావా ఏమి? ఎప్పుడో 2002లో 2023లో 2022లో చూసిన నీ కామెంట్స్. ఇంకా నువ్వు జాబ్ల కోసం ట్రై చేసి ఎట్లా రా స్వామి? ఎక్కడో ఒకటి జాయిన్ అయిపోవాలి కదా, అమ్మ నన్ను చూసుకోవాలి కదా నాన్న. ట్రాన్స్కోలు జెన్కోలు కాదురా, జాబ్లో ఎక్కురా, టైం వేస్ట్ చేయమాక. సో మూవింగ్ ఐరన్, means the VRMS. VRMS means what I have to take. So VRMS, how to find out? So if you take the VRMS, that can be taken as square root of 2 square. పెద్దన్నలాగా చెప్తున్నారా స్వామి? ఏ వచ్చేసిందిరా, జాబులు ఉండవు ఫ్యూచర్లో, ఇంకా నువ్వు గవర్నమెంట్ జాబ్ అంటే కుదరదు. 2 square 4 plus 9/2. సో √17/2 आएगा आंसर. √17/2 आएगा. So this is for moving iron. This is for moving iron. This is for PMMC. Okay, understood? Chalo, let me go for the next question. Try to answer this question. Make it fast. आंसर प्लीज, इसका आंसर बताओ. तो आंसर क्या है, sawtooth wave. So VRMS है ना, so VRMS will be what, 100 by root 3. So this is 100, so 100 by root 3. So 100 by root 3 आंसर कितना आएगा, ये क्वेश्चंस को आंसर करो यार, फास्ट है. 100 divided by root 3. So that is going to 57.73 volts. So this is going to become as 57.73 volts, my dear. Chalo, let us go for some more questions. Yeah, this question dekho. A DC voltage is given by the expression V of t. DC voltage with a ripple. V of t is equal to 100 plus 10 sine omega t plus 5 sine 3 omega t volts. Measurement of this voltage is made by moving coil and PMMC. Moving current, moving errand. So if it is moving coil, what is answer? The DC voltage only. The answer is 100 volts. If it is moving iron, then it will be VRMS. So what is the VRMS of this expression? So if you see that VRMS, that will be, this is 100 square plus this will be 10 by root 2 whole square plus 5 by root 2. कितना आएगा, चेक करके बताओ यार, कितना आएगा, जल्दी बताओ यार. सती ఉన్నారా లైన్ లో, 100 by 2 25 by 2. संतु आंसर कितना, so 50 plus 12.5 plus 10,000 under root of answer. $100.312. So question asked is the difference. He is asking the difference. The difference means V1 minus V2 minus V1 is asking. 100.312 minus 100. So answer is 0.312. ये मुझे आंसर कर दीजिए. A 0 to 1 ampere moving iron ammeter has an internal resistance of 50 milliohms and inductance of 0.1 millihenry. A shunt coil is connected to extend its range to 0 to 10 amperes for all operating frequencies. The time constant in milliseconds and resistance in milliohms of the shunt coil respectively are dash. So इसका आंसर क्या है, जल्दी बताओ. See, to understand this question, we have to go for the range extension of the moving iron. So if you see the range extension of the moving iron, range extension of moving iron as an ammeter, if you see, क्या होगा, range extension of moving iron as an ammeter, if you see, what actually we are going to get. See, moving iron as an ammeter, if you check now, so this is, in addition to resistance, we are also having inductance. So definitely shunt components also should have both. Okay, so if you see, this is the moving iron. So in addition to resistance, generally in PMMC we have resistance, and this one is LM, and this is my RSH, this is my LSH. So this is the total I, so this is the IM. Okay, got it? So this is my expression. Okay. All of you are there in the live, एक बार thumbs up दिखाइए बेटा. So now I can take the VM is equal to VSH. So this voltage I am taking as VM, this voltage I am taking as VSH. Okay, so this is the VM and this is the VSH. So VM is equal to IM into ZM होगा, VSH is equal to ISH into ZSH होगा. So IM by ISH is equal to ZSH by ZM. So ZSH के लिए हमने फॉर्मूला ले सकते हैं स्क्वायर रूट ऑफ RSH square plus omega LSH whole square, and this will be RM square plus omega LM whole square. So now if I am taking that RSH by RM, RSH square RSH by RM comes out. So this will be 1 plus omega LSH by RSH whole square by 1 plus omega LM by RM whole square. So IM by ISH I can take it as IM by ISH I can take it as RSH by RM, RSH by RM, the square root of 1 plus omega. So this is what time constant of the shunt by time constant of the meter. If time constant of the shunt is equal to time constant of the meter, then this formula will become as IM by ISH is equal to RSH by RM. So from this, RSH is equal to RM into IM by ISH. ISH I can take it as I minus IM. So if I take IM common, it will become as I by IM minus 1. So now this gets cancelled. I am going to get the formula as PMMC ammeter RM minus M minus 1. So once you get the RSH, you can find out the LSH. Why? Because L by R is equal to time constant. L by R is equal to time constant. LSH, time constant of the shunt, time constant of the motor, both are same. This is LSH by RSH. This is LM by RM. So now if I want to find out the LSH, so what is the LSH? That is LM by RM into RSH. Okay. So let's make it. This is RSH and this is LSH. Understood? So that's how you have to find. Richa ji, namaskar. Santosh ji, Katti, namaskar. Yeah. Now please answer this question. Try to answer this question now. आई एम गिविंग सम टाइम फॉर यू, प्लीज ट्राई टू आंसर दिस क्वेश्चन। मैं पोल भी दे रहा हूं लेकिन पोल नहीं आ रहे, ट्राई टू आंसर, मेक इट फास्ट। कितना आ रहा है रीचा? Nobody has given the answer, simply watching the lecture. कितना आ रहा है? 2 5.5, ऑप्शन ए आएगा। व्यू रिजल्ट्स लीडर बोर्ड पर कोई भी नहीं है। चलो लेट अस सी हियर, लेट मी राइट दिस क्वेश्चन। मूविंग आयरन अमीटर ना, सो आई विल राइट लाइक दिस। सो दिस इज द IM, so this is the RM, this is the LM, and this is my RSH, this is the LSH, this is the I. What is given? 0 to 1 ampere, so this is 1 ampere. Moving iron ammeter has internal resistance of 50 milliohms, this is 50 milliohms, and inductance of 0.1 millihenry, this is 0.1 millihenry. A shunt coil is connected to extend the range of 0 to 10 amperes, 10 amperes. The time constant in milliseconds, resistance milliohm shunt coil is asking. So first of all, what is the RSH? RSH we can take directly formula, ammeter formula, Rm by m minus 1, Rm by I by Im minus 1. So meter resistance is 50 milliohms, 50 into 10 power minus 3. I will be how much? 10. Im is how much? 1 minus 1. So 50 by 9 into 10 power minus 3. So answer कितना आएगा? 50 by 9 बोलो तो 5.55 milliohms. So RSH is equal to 5.55 milliohms. So time constant tau m is equal to Lm by Rm. So Lm is equal to 0.1 millihenry. Rm is equal to 50 milliohms. So 0.1 by 50, 1 by 500, 2 milliseconds. So tau m is equal to tau sh generally. So answer is 2 milliseconds and 5.5 milliohms. Option A is the right answer. जिंदा हो, जीवन में हो। चलो, let us go for the next topic. That is a power measurement. So power measurement is done with a dynamometer, my dear. आज का टॉपिक डायनामोमीटर है। So dynamometer can be suitable for the current measurement, voltage measurement and the power measurement. It is suitable for both AC DC, voltage AC DC, power also AC DC beta. Shivaramakrishna, Gundru, nice to see you. See here, dynamometer is a combination of PMMC and moving iron. PMMC is a permanent magnet moving coil, so it is suitable for DC current and DC voltage. And moving iron is electromagnet moving disc, so it is suitable for both DC and AC components. So now what I am going to get here, permanent magnet and electromagnet. So for dynamometer feature, what we are taking now, from moving iron we will take electromagnet, and from PMMC we will take moving coil. So that's what the dynamometer. So dynamometer is a transfer type instrument. It will take moving iron feature electromagnet and will take PMMC feature moving coil. That's why it is called as EMMC. So dynamometer is called as what? EMMC beta. Okay. So how this EMMC will work out? See here. Dynamometer EMMC contains two coils. So actual construction of the dynamometer will be like this. So this is the actual construction of the dynamometer. Between the two fixed coils, one moving coil is kept. So this fixed coil, when a current travels, it acts like a magnet. Okay, when a current travels here, it also acts like a magnet. So between the two magnets, there is a moving coil, also a magnet. So between the two magnets, one other moving coil is also acting like a magnet, is suspended. So because of the mutual induction force, there is a deflection force. The deflection makes the pointer to move like this. Okay, and this will continue even for the both positive pulse and the negative pulse. Positive and negative pulse दोनों के लिए this particular momentum will continue like this. Okay, so that is the purpose of the dynamometer. So dynamometer का expression देखो, this is the dynamometer का expression. So if you see the dynamometer expression, so both the coils are there. One is a fixed coil, other one is a moving coil. फिक्स्ड कॉइल का सेल्फ इंडक्टेंस L1 है, मूविंग कॉइल का सेल्फ इंडक्टेंस L2 है, एंड ये दोनों के बीच में म्यूचुअल इंडक्टेंस M है. देन द फॉर मूविंग आयरन द डिफ्लेक्शन टॉर्क एक्सप्रेशन हाफ I स्क्वायर dl by d थीटा है, and for dynamometer it will be TD I square d by d theta of L1 plus L2 minus 2m, or plus or minus 2m ले सकते हैं, plus क्लेव, no problem. So if I take this L1 and L2 both are constant, then the expression will become as half I square 2 d theta, this 2m by d theta. So 2 gets cancelled, then option is I square dm by d theta होगा. So deflection torque क्या होगा? Deflection torque is equal to I square into dm by d theta होगा. So please make a note of this expression. So this is the expression for the deflection torque, and the controlling torque क्या होगा? Kc theta होगा. So the expression will be theta is proportional to I square. So now if I see the expression, final expression, so dynamometer ammeter will be like this. This is I square dm by d theta, Kc theta, theta is proportional to I square. So the scale is non-uniform. So dynamometer is a non-uniform ammeter, scale will come. Okay. Next, similarly, if we go for dynamometer voltmeter, I square dm by theta is equal to Kc theta, I can be written as V by R, V square by R square. So theta is proportional to V square. So this is dynamometer voltmeter. So please make a note of these two. And next I am going for power measurement. So power measurement के लिए scenario is different. Okay. I'll come in 1 minute. Please note down the power measurement. noted the context of the ammeter and voltmeter? Have you noted the context of the ammeter and voltmeter? Why the basic purpose of dynamometer is, the dynamometer is basically not for current measurement and voltage measurement beta. Basically it is for the power measurement. Basically it is for what? Power measurement. Okay. Okay, current and measurement भी कर सकते हैं, current and voltage भी कर सकते हैं, लेकिन current and voltage के लिए हमारे पास already exclusively PMMC moving iron है ना. So then why we have to go for this particular dynamometer? See here. जो लोग आपने अकाडमिक्स के लिए प्रिपेयर हो रहे हैं, जो लोग अकाडमिक्स के प्रिपेयर हो रहे हैं, सो इसके लिए डायनामोमीटर का डेरिवेशन देखिए इधर. सो दिस इज I square dm by dt ना, I square dm by dt. So there are two currents, one is the fixed coil, other one is a moving coil. So current passing through fixed coil is taken I1, current passing moving coil is taken I2. So this is Im1 sin omega t, this is Im2 sin omega t minus 5, having a phase shift. Okay, so now if you see, this is a current coil na. Current coil constructionally different hai. Current coil is thick in size, whereas a moving coil is thin in size and lengthy. Okay na? Katti Sujata, Lingala Sathish, are you there? So if you see here, current coil will be, this is the moving coil. So this fixed coil call सकते हैं इसको pressure coil भी call सकते हैं, इसको voltage coil भी call सकते हैं, potential coil भी बोल सकते हैं. Okay, so different names भी बोल सकते हैं. So here the area is more, so resistance is equal to rho L by A. Area is more, why? Because see the thick size, diametrical area is more. When area is more, resistance is less, current is very very high. Current is very very high. Current is very very high. That's what is called fixed coil. But whereas here the length is more, the resistance is equal to rho L by A. So the length is more, and the resistance is more, the voltage is also more. So this is what we call as potential coil, pressure coil. But because of these constructional features, the currents passing may not be in phase. Please maintain the notes. Telugu students ఎవరైతే ఉన్నారో notes maintain చేసుకోండిరా. ఇది అకాడమిక్స్ కూడా ఉపయోగపడుతుంది. ఓకేనా? మీరు ఇంటర్వ్యూస్కి వెళ్ళినా, లేకపోతే జెన్కోకి వెళ్ళినా, ట్రాన్స్కోకి వెళ్ళినా, మీరు లైవ్ క్లాస్లోకి రావట్లేదు కాబట్టి పెయిడ్ క్లాస్లో ఇంత కంటెంట్, పెయిడ్ క్లాస్లో ఏదైతే కంటెంట్ ఇస్తున్నారో అదే కంటెంట్ నేను క్రిస్పీగా మీకు ఇస్తున్నా. సో అది నోట్ చేసుకోండి నీట్గా. ఓకేనా? క్లాస్ అయిపోయిన తర్వాత పీడిఎఫ్ నోట్ చేసుకోండి. ఓకే, లేకపోతే మీరు మెజర్మెంట్స్ మొత్తం చదవాలంటే ఏకేసారి ముందరేసుకొని కూర్చోవాలి, 1 month పడుతుంది అంత ఇక్కట్టే చేసుకొని చదువుకోవాలంటే. అర్థమైందా? సో ఏదైతే ఎగ్జామ్కి అవసరమో అది ఇస్తున్నా. వట్ ఎవర్ ద ఎగ్జామినేషన్ మెటీరియల్ ఈజ్ రిక్వైర్డ్ దట్ ఐఎమ్ हिंदी में बोल रहा हूँ. मैं क्या बोल रहा हूँ ना बच्चों, जो भी कंटेंट मैं दे रहा हूँ वो एकेडमिक्स के लिए भी यूजफुल होगा. जो लोग अभी बीटेक 3rd ईयर में पढ़ रहे, बीटेक 2nd ईयर में पढ़ रहे, बीटेक 4th ईयर में पढ़ रहे, आपका एकेडमिक्स के लिए भी ये कंटेंट यूजफुल होगा. एकेडमिक्स का नोट्स को भी देख सकते हो आप. ओके, क्योंकि अगर आपने खुद से मेजरमेंट्स पढ़ना है पर तो एक ही टेक्स्ट बुक है, इलेक्ट्रिकल एंड इलेक्ट्रॉनिक मेजरमेंट्स में 𝐂𝐤𝐴 और JB गुप्ता. वो टेक्स्ट बुक इतना साइज रहता है, इतना बड़ा साइज. अगर आपका क्लास आपका घर में डंबल्स नहीं है तो वो टेक्स्ट बुक दोनों को यूज कर सकते हैं दोनों. अगर एक बार आपने परचेस कर दिया 𝐂𝐤𝐴 JB गुप्ता टेक्स्ट बुक्स, सो आपके लिए डंबल्स के लिए यूज होता है एंड स्लीपिंग समय पिल्लो की तरफ से भी यूज होता है. इतना बड़ा साइज रहता है. वो बड़ा बुक को पढ़ने के लिए आपको बहुत टाइम लगता है. इससे नोट्स बनाना, उससे क्वेश्चंस बनाना बहुत टाइम लगता है. इसलिए मैं पूरा क्रिस्पी लेवल में आपको दे रहा हूँ. सो ये पढ़ के आप डायरेक्टली गेट का क्वेश्चंस करवा दो. 4 मार्क्स का वेटेज है इलेक्ट्रिकल मेजरमेंट्स के लिए. सो इतना अच्छा वेटेज आएगा आपको. लेकिन मेरा बात यह है कि गेट के बिना जो भी अदर एग्जाम्स लिख रहे हैं, अगर आपने बीटेक कंप्लीट हो चुका है, अभी एमटेक का एंट्रेंस लिख रहे हैं, और एमटेक हो चुके हैं और पीएचडी का एंट्रेंस लिख रहे हैं, अगर आप इलेक्ट्रिकल बच्चे हैं, सो इफ यू आर इलेक्ट्रिकल स्टूडेंट, इफ यू आर गोइंग फॉर एमटेक, प्राइवेट यूनिवर्सिटी एमटेक, बहुत सारा प्राइवेट यूनिवर्सिटी भी आजकल एमटेक में आ चुका है ना. प्राइवेट यूनिवर्सिटी बहुत सारा है. अगर साउथ इंडिया में देखो तो बहुत सारा यूनिवर्सिटी आ गए. SRM यूनिवर्सिटी है, अमरावती यूनिवर्सिटी है, LP यूनिवर्सिटी है. ओके, एंड साउथ इंडिया में केरला में बहुत सारी यूनिवर्सिटी, अन्नामलाई यूनिवर्सिटी है, पांडिचेरी यूनिवर्सिटी है, तमिलनाडु में ऑलमोस्ट सम 40 to 50 यूनिवर्सिटीज आर देयर. नॉर्थ इंडिया में भी बहुत अच्छा यूनिवर्सिटीज है. प्राइवेट यूनिवर्सिटीज बहुत आ गए. तो अगर प्राइवेट यूनिवर्सिटी में भी आप एमटेक करना चाहते हो, अगर आपको एंट्रेंस एग्जाम लिखना पड़ता है, सो वहां भी आपको मेजरमेंट्स बहुत इंपॉर्टेंट है. और कोई ना कोई स्टेट लेवल इलेक्ट्रिसिटी बोर्ड का एग्जाम पेपर लिखना चाहते हो, IAS के लिए तो बहुत अच्छा वेटेज है. 100 मार्क्स का वेटेज है यार. 100 मार्क्स का वेटेज IAS. देखो IAS में बहुत अच्छा वेटेज है ये. सो इसलिए मैं बोल रहा हूं, ये सब्जेक्ट एक बार अगर नोट्स प्रिपेयर करे तो आपको बार बार ये नोट्स यूजफुल हो जाएगा. ओके ना? चलो, so that's why sometimes I will spend some time on the theoretical context also more. उसका पर्पस ये है कि थियोरेटिकल कंटेक्स्ट अगर आपके पास रिफरेंस है तो आप टाइम वेस्ट नहीं कर सकते टेक्स्ट बुक ओपन करके, टेक्स्ट बुक पूरा पढ़ के. आजकल हम AI जमाना चल रहा है ना. ఓకే, ఎలా ఉన్నారు సుజిత? మన తెలుగు రాష్ట్రాల్లో అందరూ, సంతోష్ గారు, లింగాల సతీష్ గారు, శివరామకృష్ణ గారు. యా, all fine. Chalo, so if you see the current of the current coil, that is Im1 sin omega t, I2 is the current passing through the pressure coil, that will be having a phase shift sin omega t minus phi. Okay, so now the deflection torque actual expression क्या है, I square dm by dt था. हमने दोनों सीरीज में लिया है, so सेम करंट जा रहे हैं प्रेशर कॉइल करंट कॉइल के बीच में, सेम करंट जा रहा है, इसलिए हम I1 I is equal to I2 लिया. But actually practically I1 cannot be equal to I2. That's why this I square can be split into two parts, I1 into I2 dm by dt. So मुझे एवरेज टॉर्क का एक्सप्रेशन क्या होता है, 1 by t इंटीग्रेशन ऑफ 0 to t dt dt होता है, td dt. So what is the td? That is I1 I2 dm by dt. That's what we got it. Okay, so what is I1? So I1 I can take it as Im1 sin omega t, and I2 what it take it as I2 sin omega t, Im2 sin omega t. This is Im1 sin omega t, and this is Im2 sin omega t minus phi. This is sin omega t minus phi dm by dt t is equal to omega t liya. Okay, so this is omega t minus phi. Why? Because the pressure coil is having this is a current passing through the moving coil. It is also called the current passing the pressure coil. This is the current passing the current coil. Okay, so दोनों के बीच में there is a phase shift phi. Okay, there is a phase shift phi. So now इसको simplify करने की कोशिश करेंगे. So I have taken the Im1 Im2 out dm by dt. So 1 by 2 pi, see here, this is 0 to 2 pi na, so 1 by t means 1 by 2 pi. So 1 by 2 pi 0 to 2 pi sin omega t, and sin omega t, sin of omega t minus phi d omega t. So I'm multiplying divide with 2 both sides. So here 2 multiplying dividing, so that will become as 4 pi. So this is 2 sin A sin B. So this is 2 sin A sin B. This is 2 sin A sin B. 2 sin A sin B means cos of A minus B minus cos of A plus B. So if you simplify, cos phi minus cos 2 omega t minus phi आएगा. So इसमें से ये cos 2 omega t इंटीग्रेशन करते हो sin टर्म आएगा, sin ऑफ इंटीग्रेशन विल बी 0 हो जाएगा. So अगर आप ध्यान से देखो तो ये क्या होगा, Im1 Im2 dm by dt 1 by 4 pi here हो गया, 0 to 2 pi ये हो गया, cos phi d omega t minus, so 0 to 2 pi cos 2 omega t minus 2 pi. Okay, so cos phi बाहर निकलेगा, 0 to 2 pi d omega t है. This particular sign, if you make integration of sin x will be 0. Okay, so automatically 1 by 4 pi cos phi आएगा. So ultimately हमको final expression ये आएगा, 2 pi gets cancelled. So Im1 into Im2 into dm by d theta into 1 by 2 cos phi, which can be written as Im1 Im2 by 2 cos phi dm by d theta, which can be written as Im1 by root 2 Im2 by root 2 cos phi dm by d theta. Please make a note of this derivation. Derivation note చేసుకోండమ్మా. ओके सी फाइनली हमको क्या एक्सप्रेशन आ रहा है, देखो ध्यान ध्यान से. Deflection torque is equal to ICC IMC cos phi dm d theta. So this IMC I can write it as VMC by R. Why? Because if you see this all to get the power formula. See, actually this is the current coil and this is a moving coil. Moving coil, if you consider the resistive, moving coil and moving coil voltage both will be in phase. That means VMC and ICC, the angle will be phi. So this is what our power factor angle. So ICC is nothing but current coil, VMC is nothing but V pressure coil. So this particular angle is the phi. VPC ICC के बीच में power factor angle आ चुका है. So finally the deflection torque is proportional to VPC ICC cos phi, which is nothing but the average power आ चुका है. Okay, so now if we see the steady state, so if you go for the steady state, at steady state TD is equal to TC. So ICC VPC cos phi 1 by R dm by theta, TC is equal to KC theta, this one. Okay, so at steady state what I am going to get, ICC VPC cos phi 1 by R dm by theta is equal to KC theta, ICC VPC cos phi 1 by R KC dm by theta is equal to theta. So theta is coming as a pure function of average power. So theta is coming pure function of average power. So for dynamometer ammeter, theta is coming as I square. Dynamometer voltmeter, theta is coming as V square. For this it is coming as average power. Average power. Theta is proportional to average power. Note कर दो बेटा जल्दी से जल्दी. So these are the final expression. So here comes the non-uniform. This is AC and DC. So this is the non-uniform scale, and this is also AC and DC. This is also non-uniform scale. This is DC and AC. So uniform scale. Uniform scale आएगा. So finally the power curve will be uniform. The power curve will be perfectly straight line. So please make a note of these points. Please make a note of the points. Everything is noted? Chal. Now let us go for the next context of the connections. If you see the dynamometer wattmeter, in dynamometer wattmeter, what the special measurement of this is power measurement. So power measurement के लिए हम use करते हैं ये. Okay. So fixed coil is current coil. Fixed coil is current coil. So current coil is thick in size. Remember this point. Thick in size, smaller in length. That's why the resistance is less, current is more. So it is a thick in size. That's what I was talking. Thick in size. So current will be more. That's why it is called current coil. Whereas a moving coil is like this. Moving coil is a pressure coil. So moving coil is also called as potential coil or pressure coil. So thin in size, longer in length. So this is thin in size and longer in length. Thin in size and longer in length. समझ में आपको? Thin in size and longer in length. चलो, let us go for the next. So if you see the dynamometer wattmeter connections. So now the most important point. All of you are ready है? एक बार मुझे thumbs up दिखाए. One of the important. See मैंने बहुत टाइम दे रहा हूँ आपको टाइम को नोट्स करने के लिए. नोट करो, पढ़ो, क्योंकि थ्योरी पार्ट है ना. थ्योरी पार्ट के लिए आप टेक्स्ट बुक को रेफर करना पड़ता है. इतना रेफरेंस करने की जरूरत नहीं है. कंटेंट को मैं पैक करके आपको दे रहा हूं. थोड़ा सा फास्ट में जाओ यार. वाई? बिकॉज बहुत सारा कंटेंट पढ़ना है. Yes, Lakshman. So there are two types of connections, MC connection, LC connection. So if the pressure coil is, where the pressure coil is connected, if the pressure coil is connected at the main side, if the pressure coil is connecting at the main side, so this side, pressure coil is connected to the main side, then it is called as MC connection. So this is what we call as mains side connected. Mains side connected. Next, if the pressure coil is connected to this load side, then we can call it as LC connection. So this is what we call as load side connected. Load side connected. So this is the main side connected, this is the load side connected. అगर ఆగరా భాయ్ లక్ష్మణ్ భాయ్ ఎలక్ట్రానిక్ మెజర్మెంట్ స్టార్ట్ చేసినప్పుడు చెప్తా కదరా భాయ్, నీకు కావాల్సిన టాపిక్ కావాలంటే ఎట్లా రైతుందిరా? ఆర్డర్లో పోతున్నాం మనం, ఆర్డర్ ప్రకారం వెళ్ళాలి. ఇక నేను నచ్చిందే సందురా భాయ్ నాకు ఇది కావాలరా అంటే ఎట్లా అవుతుందిరా? తెలుగు అర్థం చేసుకో. ఆర్డర్లో పోతున్నా నేను, ఐఎమ్ గోయింగ్ ఇన్ ఆర్డర్. इलेक्ट्रॉनिक मेजरमेंट्स है ना, उस समय हम डिस्कस करूंगे यार. चलो, मेन साइड कनेक्शन. सो नाउ इफ यू सी, if the connection is here, actual power is what? This is a true power. So this is a true power. So true power का फॉर्मूला क्या होगा? वोल्टेज across this load, current passing through the load and cos phi होगा. VL IL cos phi होगा. But the measurement value is what here? In addition to the true value, see the connection part clearly. The connection is here. So the connection is part is here now. That means if you see with respect to this, so this power is also coming to picture. So the measurement value involves In addition to this power consumed by the load, there is a power consumed by the current coil, the resistance. So power consumed by the current coil is the extra. So very interesting context this is. So अभी क्या होगा? What is the power consumed by the current coil? I square or CC. So this is a measurement value. इसके ऊपर बहुत सारा टाइम्स हमको क्वेश्चन आ चुका है. हिंदी बच्चों लाइव में हो, नोट कर दो. एरर्स आर वेरी इंपॉर्टेंट टॉपिक इन अवर मेजरमेंट. बेटा एरर कहां भी आ सकता है. सीआरओ पर पूछ सकता है, ब्रिड्जेस पर पूछ सकता है, वाटमीटर पर पूछ सकता है, कहां भी आ सकता है यार. ఏం లక్ష్మణ్ టిఫిన్ చేసి వచ్చినా మెల్లగా? ఇప్పుడే వచ్చినావా క్లాస్ కి? सती सुजाता, संतोष जी, नाश्ता हो गई? तनिष भाई, yeah, noted. चलो. Now if you go for the load side, what is the load side connection? अगर लोड साइड कनेक्शन देखो बेटा, ट्रू वैल्यू क्या होगा? ट्रू वैल्यू, द ट्रू वैल्यू विल बी, दिस ट्रू वैल्यू इज VL IL cos phi होगा, VL IL cos phi होगा. लेकिन मेजरमेंट वैल्यू क्या होगा बेटा? So if you see this time, it is load side connected, so the connection is here. So if you see the connection part, so this particular loop you have to consider. Am I right or not? That means the measurement power will be in addition to the this power. So this power also will come into picture. So true value plus power consumed by the pressure coil. Power consumed by the pressure coil, what we can take, this is the voltage, this voltage and this voltage will be same. Try to understand, both are parallel connections. So WTV plus V square by RC. Okay, so please make a note of this. So there is an error here and there is an error here. Okay, expected question. So आप ऐसा याद रख सकते हैं. How you can remember? लक्ष्मण भाई उन्ना, लक्ष्मण आर यू फ्रॉम तेलुगु? अगर आपको सीआरओ चाहिए, ऑसिलोस्कोप चाहिए, अट्ला अड़गा रादरा भाई, वेट चाहिए. अब इलेक्ट्रिकल मेजरमेंट्स पढ़ रहे हैं, उसके बाद इलेक्ट्रॉनिक मेजरमेंट्स आएगा. अभी पावर मेजरमेंट चल रहे हैं, पावर के बाद एनर्जी होगा, एनर्जी के बाद इलेक्ट्रॉनिक मेजरमेंट्स यहाँ आएगा. अगर ये दोनों कनेक्शन देखे तो एरर किसकी वजह से आ रहे हैं? एरर इज कमिंग ओनली बिकॉज ऑफ द कॉइल विच इज नियरेस्ट टू द लोड. अगर ये कॉइल नियरेस्ट टू द लोड है, इसकी वजह से एरर आ रहा है. ये कॉइल नियरेस्ट टू द लोड है, इसकी वजह से एरर आ रहा है. समझ में आपको? सो प्लीज नोट करो. अगर आप नोट करें तो मैं क्वेश्चंस के पास जाऊंगा जल्दी से जल्दी. यस सुभाष, बताओ सुभाष क्या है? morning, good morning. थैंक यू बेटा, थैंक यू सुभाष जी। नोट कर दिया बेटा, एमसी कनेक्शन, एलसी कनेक्शन। मैंने एक टिप बताया आपको, ट्रिक बताया, whether it is MC connection or LC connection, the error is due to which coil? MC बोलो तो मेंस, LC बोलो तो लोड। मेंस कनेक्शन हो, लोड कनेक्शन हो, the error is always due to the coil whichever is connected to the load side. Okay, chalo. So that's what. Now let us go for this question. Try to answer this question. IIT Delhi 2004 का सवाल है। The circuit in the figure is used to measure the power consumed by the load. The current coil and the voltage coil of the wattmeter are 0.02 ohms, 1000 ohms resistance respectively. So these are resistance of the current coil. Always हमेशा problem में याद रखो, current coil का resistance कम होगा, इसलिए वो current बोलते ना, current coil का resistance कम है, current passing is more. So these are resistance of the current coil है, and ये है resistance of the moving coil or pressure coil. Always remember in the question, whichever is less, that is the resistance of the current coil, whichever is more, that is the pressure coil. Okay, and UPF बोलो तो unity power factor. So unity power factor, इसका आंसर बताइए बेटा। इसको अगर ध्यान से देखो तो ये क्या कनेक्शन है? It is connected to the main side. Pressure coil is connected to the main side. So that's why it is called as MC connection. It's called as MC connection. नोट कर दो बेटा जल्दी, ये प्रॉब्लम कंप्लीट करके जल्दी जाएंगे हम फटाफट। आंसर बताइए, कोई भी बोल सकते हैं आंसर को। मैंने आपको हिंट दिया, MC कनेक्शन और LC कनेक्शन, जो भी कनेक्शन हो, error is due to the coil whichever is connected to the load side. So उसका प्रॉब्लम का करने के लिए first of all what is the data given? So given data let us note first. What is the given information? The circuit figure is used to measure. What is the circuit? This is MC connection circuit. MC connection. Power consumed by the load. The current coil and the voltage coil of the wattmeter are 0.02 ohms and 1000 ohms. So resistance of the current coil is 0.02 ohms and resistance of the pressure coil is equal to 1000 ohms. The measured power compared to the load power will be dash. The current passing through the current coil is 20 amperes. Cos phi is equal to given as unity power factor. This is current passing is load current also. And the voltage across the load is given as 200 volts. So this is all information is given. So now first true power we can calculate. The true power is always power consumed by the load, that is VL IL cos phi हो सकता है. So that is 200, current is equal to 20 amperes, cos factor is equal to 1. So answer is 4000 watts. Khatam. Next. The measurement value is equal to what? In addition to the true value, there is a power extra. What is the extra? Connection is here. So connection is here means it contains the current coil also. Sorry. The connection is here means it contains current coil. So power consumed by the current coil. So true value is 4000 watts. Current consumed by the current coil is I square RCC. So this is 4000. Current passing here is 20 square. RCC is equal to 0.02. कितना हो रहा है ये? 400 by 100. 4008 watts. खत्म. So this is the measurement value. This is the true value. So percentage error निकालो कितना आ रहा है. So answer आ रहा है option C. So percentage error is equal to Got it? जिंदा हो जीवन में एक बार मुझे थम्स अप दिखाइए. सुजाता जी, संतोष जी, सुभाष जी. Now I am giving this question as an assignment for you. So as a homework I am giving this question. Please try to do it. And this question also I am giving as a homework. Please try to do it. Okay? चलो आज के लिए बस है. नेक्स्ट क्लास में हम एनर्जी मीटर डिस्कस करना है, बट इसके पहले मैं 2 वाट मीटर डिस्कस करके देन आई विल गो फॉर द एनर्जी मीटर. ओके वाह. I have given some question as assignment, so please solve that question as an assignment. आपको नोट्स मिल रहा है बेटा? Are you getting the notes properly? You are getting the notes properly or not? Yeah. क्लास होने के बाद आपको पीडीएफ मिल जाएगा, वो पीडीएफ को ले लो. So आज का क्लास में हमने मूविंग करंट खत्म कर दिया है. Okay, so this problem is our homework. This problem is also homework. And बच्चों अगर आपने YouTube सेशन देख रहे, मेरा YouTube में आपको आंसर्स के लिए जो डाउट्स के लिए आप ये टेलीग्राम चैनल आप फॉलो कर सकते हैं. प्लीज फॉलो दिस पर्टिकुलर टेलीग्राम चैनल. और 2 दिन चलेगा क्लास. एनर्जी मीटर इलेक्ट्रॉनिक मेजरमेंट से हम क्लोज करेंगे. ओके वाह. Thank you one and all. Okay, enough for today. So please do solve these problems as assignment questions. I've given this question as a homework, this question also as a homework. Homework questions miss kat karna. This question also homework. This question also as a homework. This question also as a homework. 5 क्वेश्चन मैं दे रहा हूं होमवर्क के लिए, करके आ जाओ. प्रैक्टिस करना इंपॉर्टेंट है. थैंक यू. चलो, सो प्लीज फॉलो माय टेलीग्राम ग्रुप. टेलीग्राम ग्रुप में मैं अपडेट्स देता हूं. थैंक यू संतोष जी.